more solving exponential equations and more interesting exponential equations today. And these last few problems in your, oh, you get to skip 62.
Yes. Because I don't like the number 62.
Didn't work. All right. These last couple are word problems, and you should be fine. Read the equation, figure out what the variables represent.
Yo, I'm gonna go tell you to shut up.
The word problems are, like I said, pretty easy. You just have to plug in. You just have to decide where do you plug in the number and then solve. Okay, so it's just the same thing, but it shouldn't be too bad. You do need to get that finished as well. I want you to do them. How do you do this one? What should you do first? Subtract the 7. Okay, so we get 2e to the x equals -2, and then divide by -2, which gives you 1, and then what? Natural log both sides. By taking a natural log, that allows our power to drop down. So, whoops. So we get x times the natural log of e equals the natural log of 1. What is the natural log of e? 1. Which means x equals the natural log of 1. What's the natural log of 1? 0. So we get x equals 0, which you might have known here, where you had e to the x equals 1. Could you just think about that and get right there? No. E to what power gives you 1? 0. Any base to a power of 0 equals 1. Okay, so something to think about. All right. So we're doing more of that today. We've got interesting equations today. Lots of different kinds of exponential functions. Let's do. Solve the equation round to the nearest thousandth. So these are the directions from your book. So thousandths, tenths, hundredths, 3 decimal places. The first one, we have e to the 2x minus minus 3 e to the x plus 2 equals 0. Definitely an exponential equation, very interesting. What do you think you do for that? Factor. Smart. That's right. It's totally correct. Yeah, this is the same form as x squared minus 3x plus 2 equals 0. It is factorable. So let's talk about that. It is what we call quadratic in form. So we've got 3 terms. You trinomial, try to factor. So we want to say what times what is e to the 2x? E to the x times e to the x. Very good. So let's talk about y for a second. E to the x times e to the x. They have the same base. What are you allowed to do to the exponents? Add the exponents. And that's where we get e to the 2x. So pretty easy to do that. And then last times last has to be positive too. Copy. All right, -2 and -1. And so then what can we do? Set each bubble equal to 0. So we get e to the x minus 2 equals 0, and we get e to the x minus 1 equals 0. So I'm going to go ahead and add the 2. And then how do you solve from there? Natural log both sides. Good. So our power gets to fall down. X times the natural log of e equals the natural log of 2. What is the natural log of e? 1. So we get x equals the natural log of 2, which is a beautiful exact answer, but they actually want us to round it off. And so we get 0.693. Tenths, hundredths, thousandths. Yeah.
What's it?
They wanted me to cover. Another teacher was like, I'm teaching. Okay.
Should have said
Sure, no problem. My kids are boom. All right, so good. E to the x equals 1. What's x? 0. Very good. All right, so 2 solutions there. Again, e to a power of 0 equals 1. Okay. Letter B. We have 500 divided by 100 minus e to the x over 2 equals 20. This is a different kind of exponential function. We'll find more out about this after break. This is, I believe, a logistics curve, right? An exponential function. It's a logistics curve. Logistics curves are totally cool. All right, I'll talk more about those later. What do you want to do to solve that? Cross multiply. Very good. Think about this as 20 over 1, and then we can cross multiply. So I get 1 times 500 is 500, and I'm going to have 20 times 100 minus e to the x over 2. I could distribute the 20. What else could I do with the 20? Divide the 20, which is what I would prefer to do. So we get 25 equals, God bless you, 100 minus e to the x over 2.
No time over.
All right, now what? Minus 100. Subtract 100, we get negative 75 equals negative e to the x over 2. Then what? Negative 1. Yeah, this is negative 1 times e. We need to get rid of that negative 1, so we're going to divide by negative 1. Or multiply. So 75 equals e to the x over 2. And then what? Natural log both sides. That's going to allow our power to drop down in front. So we have the natural log of 75 equals x over 2 times the natural log of e. What's natural log of e? 1. And how do you get x by itself? Times by 2. So x equals 2 times the natural log of 75, which is a totally excellent answer. And probably on a test you can expect to see that answer. But rounded off, we get 8.635 for our approximation. Wasn't that fun? It's good stuff. It's real good. All right, a couple more. Letter C, 1 plus 0.065 over 365, quantity to the 365t power equals 4. This looks like something. What does this formula look like? Compound interest. Very good. Compound interest. That was the formula 1 plus r over n to the nt. There's usually a p in front. So this is something we'll be solving when we get back, but we have to set it up. So you'll actually be given a word problem, and then you'll basically turn it into this. This would be something like, hey, you've got a savings account that has an interest rate of 6.5%, compounded daily. And we want to know how long does it take to quadruple in value. All right, whatever your investment is, how long would it take for that amount of money to quadruple? So that's really what this question is answering. What I want you to realize is that all of this base is just a number. It's a crazy number, like 1.003. I don't know what it is. It's some crazy, ridiculous number, but it is just a number. So you could plug it into your calculator. It's a number one. Yeah, it's a number. It's one. All right. Okay. But I'm going to leave it. And in order to solve, I need to get my t out of the exponent. So what should we do? Natural log. Yes, right off the bat, natural log. Natural log allows me to drop my power down. And the reason I can't do anything inside of these parentheses, it's all trapped right now by that exponent. So 365 times t times the natural log, all that garbage. And it's fine to call it garbage. So we got a bunch of stuff with t. How do you get t by itself? Divide. A lot of division, right? We can divide off the 365. Boop. We can divide off the natural log, all that garbage. And they go away, so the natural log of all that garbage. 0.65 over 365. All right. And now here's the tricky part. I need you to plug that into your calculator to make sure you can do it correctly. So get out those calculators and plug that in, please. What do you need to remember? Parentheses. Very good. Do it. Do it now. How many years does it take for it to quadruple? 21.330. Rounding that to the thousandth. Again, half the battle is really just getting it in your calculator correctly, so be careful.
You have to put years.
Well, you don't know that the unit is years in this problem, technically. So, all right, last one. Letter D comes straight out of your problem set today. There are 4 problems like this one, and I just chose one of those, so really one is already done for you. And these are, if I don't know, I haven't ever pointed out in this class, I think, there's a little icon in your book like this. It's got a little box around it, and it's this little stretched S thing. That's actually an integral. That's calculus. So every time you see this little icon in your book, it means that, hey, this is something from calculus. Okay? So we can teach the mechanics, but we just don't know what they mean. All right? This is actually pretty easy. So we have an equation, negative x squared e to the negative x plus 2x e to the negative x equals 0. First of all, it's set equal to 0. Always a good plan when things are set equal to 0. It's a really good thing it's Thanksgiving because like y'all are all sick and it's just grossing me out. So. All right. So my first question to you is, how many terms do you see? 2 terms. Very good. Important to see those 2 terms. What else do you see when you look at those 2 terms? GCF. GCF is what I heard. That's huge. Greatest common factor is the biggest thing you need to take away from this class. It's huge. It's everything in calculus. So you'll notice, what do they have in common? E to the negative x. They both have e to the negative x. That's excellent. What else do they have? They both have an x. All right, and so we want to take out the x, and we want to take out the e to the negative x. And what's left over? Negative x plus 2. Good. So this was x squared. We pulled out one of the x's. That left an x behind. All right, now what we've done is we have the zero products property. We got a bubble here. We got e to the negative x times x. We get to set each thing equal to 0 and solve. So we set x equal to 0. Done. We set e to the negative x equal to 0. I'll do that in a minute. And we set our bubble negative x plus 2 equal to 0. What's x? 2. Move the x. Yeah. All right, let's do the thing in red there. E to the negative x equals 0. How do you solve? Natural log. Ellen is a TV show. Right. So negative x times the natural log of e equals the natural log of 0. We know the natural log of e is 1. What's the natural log of 0? Error. Big fat error. Why? Domain is correct, sir. Very good. Oh, is that what your calculator told you?
Yeah.
Domain error? Why?
Because it's A.
Remember the graph for a log function. We've got the log right, and it had that vertical asymptote at x equals 0. We could not include 0. Domain error. Okay, had to be greater than 0. All right, so 2 solutions, 0 and 2. Not so hard, right? Looks complicated, but it's really not. Do you have any questions for me? Cool. You guys can work on CP 76.
Oh, you haven't done yet?